Myself, Afrin Sultana. Today, my seminar topic is logic gates from the chapter Boolean theorems and logic operations. The basic definition of logic gates. Logic gates are the basic building blocks of digital circuits that take one or more binary inputs, 0 or 1, and produce a binary output based on a specific logic function. Each gate implements a Boolean function, the logic used in computers. Here we see the some most common types of logic gates. First one AND gate, second one OR gate, third one NOT gate, fourth one NAND gate, fifth one XOR gate, sixth one XNOR gate, seventh one XNOR gate. And we see the detailed explanation about the logic gates. First one AND gate. The symbol of the AND gate is A dot B or A and B. The function of the logic gate is output is 1 only if both inputs are 1. The symbol of the AND gate is as shown in the figure. The truth table of the AND gate in the below. We take inputs as A and B and output as output. First one, if we take A equals to 0 and B equals to 0, the output becomes 0. A equals to 0 and B equals to 1, the output becomes 0. We take A equals to 1 and B equals to 0, the output becomes 0. If we take A equals to 1 and B equals to 1, the output becomes 1. Because the function of the AND gate is output is 1 only if both inputs are 1. Here we take first one, A equals to 0 and B equals to 0. No ones are present in the inputs, so the output becomes 0. And we take A equals to 0 and B equals to 1. Here only one is present in output B, so the function is not satisfied, so output becomes 0. And also third one is not present two inputs as 1, so the output becomes 0. In last case, if we take A equals to 1 and B equals to 1, in both the inputs are 1, so the output becomes 1. This is about the AND gate. Second one, OR gate. Symbol is A plus B or A or B. The function of the OR gate is output is 1 if at least one input is 1. The symbol of the OR gate is as shown in the figure and truth table as shown in below. If we take inputs A and B and the output as output, if A equals to 0 and B equals to 0, the output becomes 0. If we take A equals to 1 and B equals to 1, the output becomes 1. A equals to 1 and B equals to 0, the output becomes 1. A equals to 1 and B equals to 1, the output becomes 1. Because the function of the OR gate is output is 1 if at least one input is 1. In first case, A equals to 0 and B equals to 0. Here at least one input as not 1, so the output becomes 0. If we take A equals to 1 and B equals to 0, here at least one input as 1, so the output becomes 1. And A equals to 0 and B equals to 1, here at least one input as is present, so output becomes 1. Last one, both inputs are 1, so the output becomes 1. And this is about OR gate. And third one, NOT gate. It is also called as inverter. The symbol of the inverter as shown in the figure. The symbol of the NOT gate is not A. The function of the NOT gate is reverses the input. If input is 0, output is 1 and vice versa. The truth table of the NOT gate is as shown in figure below. If we take input as A and output as output, we take A equals to 0, the output 1. If we take A equals to 1, the output is 0. Because the function of the NOT gate is reverses the input. So we take A equals to 0. The reverse of 0 is 1, so output becomes 1. If we take A equals to 1, the reverse of 1 is 0, so the output becomes a 0. And this is about the NOT gate. And fourth one, NAND gate. It is the combination of NOT and AND gates. The function of the NAND gate is output is the opposite of AND, and it is 0 only both inputs are 1. The symbol of the NAND gate is as shown in the figure. The truth table as shown in the below. If we take inputs as A and B and output as output, if A equals to 0, B equals to 0, the output becomes 1. We take A equals to 0 and B equals to 1, the output becomes 1. If we take A equals to 1 and B equals to 0, the output becomes 1. If we take A and B also 1, the output becomes 0. Because the function of the output is the opposite of AND. It is 0 only when both inputs are 1. Here first one is we take A equals to 0 and B equals to 0, so the output becomes 1. And a equals to 0 and b equals to 1. Here we take 0 and 1, so the output becomes 1. And third one we take a equals to 1 and b equals to 0. If we take here, the output becomes 1. Last one we take both inputs as 1, so the output becomes 0. This is about an AND gate. And fifth one, NOR gate. It is the combination of NOT plus OR gates. Function output is the opposite of OR. It is 1 only when both inputs are 0. The symbol of the NOR gate is shown in the figure. The truth table of NOR gate is as given below. We take inputs A and B and output as output. We take A equals to B and B equals to 0. The output becomes 1. If we take A equals to 0 and B equals to 1, the output becomes 0. If we take A equals to 1 and B equals to 0, the output becomes 0. A equals to B equals to 1, the output becomes 0. Because the function of the output is the opposite of OR, it is 1 only when both inputs are 0. Here, both inputs, if A equals to B equals to 0, the output becomes 0. Otherwise, if we take 0, 1, 1, 0, 1, 1, the output becomes 0. And this is about the NOR gate. And sixth one, XOR gate. It is also called as exclusive OR. The function of the XOR gate is output is 1 if inputs are different, 0 if the same. The symbol of the XOR gate as shown in the figure. The truth table as shown in the below. If inputs taken as A and B and output as output, we take A equals to B equals to 0, the output becomes 0. We take A equals to B equals to 1, the output becomes 1. We take A equals to 1, B equals to 0, the output becomes 1. We take A equals to B equals to 1, the output becomes 0. Because output is 1 if both inputs are different, 0 if the same. Here A equals to B equals to 0, the inputs are same, so the output becomes 0. And A equals to B equals to 1, the inputs are same, so output becomes 0. Here A equals to 0 and B equals to 1, both inputs are different, so output becomes 1. Here A equals to 1, B equals to 0, the inputs are different, so output becomes 1. And this is about the XOR gate. And the seventh one, XNOR gate. It is also called as exclusive NOR gate. The function of the XNOR gate is output is 1 if inputs are the same, 0 if different. The symbol of the XNOR gate is as shown in the figure. The truth table as below. And we take inputs as A and B, output as output. If we take A equals to B equals to 0, the output becomes 1. We take A equals to 0, B equals to 1, the output becomes 0. We take A equals to 1, B equals to 0, the output becomes 0. A equals to B equals to 1, the output becomes 1. Because the function of the XNOR gate is output is 1 if inputs are the same, 0 if different. Here A equals to B equals to 0. We take inputs as same, 0. So the output becomes 1. Here we take A equals to 0 and B equals to 1. The outputs are different, so the output becomes 0. We take A equals to 1 and B equals to 0. The inputs are different, so the output becomes 0. We take A equals to B equals to 1. The inputs are same, so the output becomes 1. And this is about the XNOR gate. Here we see some applications of logic gates. It is used in digital circuits. First one, digital circuits. It is used in digital computers, calculators and digital watches. How it is used? Logic gates perform binary operations, zeros and ones, essential for processing and storing data. So the logic gates are used in digital circuits. Because logic gates perform binary operations, we know that zeros and ones. So it is essential for digital circuits. So it is applicable in digital circuits. Second one, arithmetic and logic units, ALUs, used in central part of CPUs, central processing units. How it is used? Performs arithmetic, add, subtractor and logical and or not operations using combinations of logic gates. So it is used in arithmetic and logic units, and it is applicable in ALUs. And third one, control system application. It is used in industrial automation, elevators, traffic lights, etc. How it is used? Logic gates decide control outputs based on multiple input condition. Example, if floor equals to 2 and button pressed, open door. So it is applicable in control systems. And next, fourth one, memory devices. It is used in RAM, ROM, flash memory, etc. How it is used? Flip-flops built using logic gates store individual bits of data. So it is used in memory devices. It is applicable in memory devices. And fifth one, timing and clock circuits. It is used in digital clocks, timers, and frequency dividers. How it is used? Gates are used to build oscillators, counters, and pulse generators. These are used in timing and clock circuits. So it is also used in digital clocks, timers, and frequency dividers. So it is applicable in timing and clock circuits. And sixth one, signal processing. It is used in digital filters, modems, audio or video processors. How it is used? Logic gates help in manipulating and analyzing digital signals. So it analyzes the digital signals. So it is used in digital filters, modems, audio or video processor. So it is applicable in signal processing. And next one, seventh one, multiplexers and demultiplexers. This is the main of the our logic circuits. It is used in data routing and communication systems. How it is used? Logic gates Logic gates controls which input or output lines are active. So the logic gates are helpful in input and output lines becomes active. So it is used in data routing and communication system. It is applicable in multiplexers and demultiplexers. And eighth one, decision making systems. It is used in AI hardware, robotics, decision control systems. How it is used? Logic gates are used to evaluate multiple conditions and generate outputs. So it is used in AI hardware, robotics, decision and control systems. It is applicable for decision making system. Ninth one, Boolean logic implementation. It is used in any system that relies on if then logic. How? Gates are used to implement Boolean expressions in circuit designs. So it is used in if then logics, and it is applicable Boolean logic implementations. And this is about the applications of the logic gates. And thank you.